And my cat has finally made an appearance, right? So she is right here and trying to bite my arm off. Okay, now you go. All right, so anyways, let's go back to what we were doing. So, um, we said that I don't know, what did we do last time? Okay. Okay, so I think what we're doing now is still we know what the central limit theorem said. The central limit theorem said that x bar is normally distributed with a mean of mu and a standard deviation or standard error of sigma over square root of n. That's what we said. This was our population mean, and this is our population standard deviation, and here is a sample size, right? So sample size. Okay, well, it's not raining anymore. Sample size. Okay, so, okay, now the thing is, we don't really know anything about the population mean or the population standard deviation in real life, right? Because we have a general population, right? So here's our population. And then in order for us to go ahead and figure out stuff about this population, we take a sample, right? But we can't get everyone in the population. So basically, we don't really know anything about the population mean or the population standard deviation, right? So we don't know what this is. We don't know what the population mean is. So what we're going to do in order for me to try to figure out what the population mean is, I'm going to try to estimate it using x bar. So very similarly to what we did with p, and we use p hat to try to estimate it. So what we're going to do to estimate all these things is we're going to go ahead and use confidence intervals. Okay, so let me go ahead and refresh this one more time. Yeah, reload. I don't know where the eraser is, and it might take forever. So I'm gonna go ahead and find a confidence interval for this particular x bar. So the whole goal is that I want to go ahead and figure out what is this mu, right? We don't know what this mu is, right? So we're gonna use x bar to try to figure it out. Okay, so why is this taking forever to load? Reload. Go ahead. Okay, I think I fixed it. So, yeah, so we were finding a confidence interval, right? So confidence interval. So how do we find the confidence interval? Okay, well, I'm just going to go ahead and tell you what the formula is, because it's basically the same thing as we found it with p hat, right? So this is the formula, right? So remember, for p hat, or for p, the confidence interval was p hat minus z star square root of p hat 1 minus p hat divided by n, right? And then p hat, the same exact thing, plus z star square root of p hat 1 minus p hat divided by n. This is what it was. So this is basically, if you look at this, this is the p hat that we had, and here looks something very similar to the standard deviation, right? Because remember by the central limit theorem, right? And then we have the z star. Well, for mu, for the population mean, the confidence interval is going to be basically the same. The statistic that we use to estimate mu is x bar. We're going to take the same thing, minus z star. Then here is going to be something that looks like the standard error of the distribution, right? So in this case, it's going to be sigma over square root of n, comma x bar plus z star sigma over square root of n. This is my confidence interval. Now notice that in order for me to do this confidence interval, this sigma, or which is population standard deviation, this must be known. So I must know exactly what sigma is. So I need to know what the population standard deviation is. Now in real life, we don't know what sigma is. I don't know what that is. So in order for me to go ahead and remediate that, I'm going to have to do something else, which we'll talk about on Monday or Tuesday, whichever class you are in. Okay, so this is the formula that I'm going to use. So write this down, right? This is the formula to find confidence intervals for means, right? That's what we're going to use. Okay, so now we're going to go back to the PowerPoint. And we're going to go ahead and do this problem, okay? Sigma is known, okay? So what we have here, so let's do part A first, or the first part. A sample size of 100 produce a sample mean of 16. So I got 100 people maybe, and I was looking for some particular variable, added them all together, divided by 100, and what we ended up getting was a sample mean of 16. Assuming the population standard deviation is 3, find a 95% confidence interval for the population mean. Okay, so now we need to figure out what is my confidence interval in this case. Okay, so what I did here, right, I went ahead and wrote down all the information, right? N is equal to 100, the mean is 16, and the standard deviation is equal to 3, right? So what I want to figure out now, I want to figure out the 95% confidence interval, okay? So remember that in order for us to find confidence interval, right, we need to figure out what our Z star is. And our Z star depends on the confidence level. So depending if it's 90%, 95%, or 99%, will depend on my Z star. So this is going to be 1.645, this is 1.96, and this is 2.575. Okay, so in this case, since we want a 95% confidence, right, we're going to go ahead and use this one, 1.96. Okay, so let's write down the problem. X bar minus Z star sigma over square root of n, X bar plus Z star sigma over square root of n. So this is the formula, right? And what we're going to do, we're going to go ahead and plug in all these values. So let's start off with this lower bound first. X bar minus Z star sigma over square root of n. X bar in this case is going to be 16, right? Minus Z star. Z star in this case is 1.96. Sigma 3 over square root of n, which is 100. So this is going to be all multiplied together. Okay, so what I'm going to do, I'm going to put this into my calculator and see what I get, right? So I'm going to go ahead and put this in. So I'm going to have 16 minus 1.96 times 3 over square root of 100, which is basically 10, right? Okay, so then this is what I get. I'm going to put it into my calculator, and I get approximately 15.412. 15.4. I'm going to leave it like that. So this is what we get for my upper bound. Now, what's my lower bound? Well, it's going to be the same thing, but now it's X bar plus Z star sigma over square root of n. So I get 16 plus 1.96, 3 over square root of 100. Okay, I put that into my calculator, and what am I going to get? So I'm going to go back up here. Okay, I'm going to change the minus to a plus. And now I get 16.6 approximately. Okay, so now we have our interval. So my interval is going to be between 15.4, because that's the minus portion, right? And then it's going to be all the way to 16.6. Okay, this is my confidence interval. So this is basically telling me that I am 95% confident that the true value is between these two numbers, right? Not X bar. X bar, this is just the sample that I got from the 100, right? But the true value, mu, right? This is for mu, for the true population, right? So we are 95% confident that the true value, or the true mean value, is between 15.4 and 16.6. Okay, I don't know if you guys can quite see. There you go. I hope this helps a little bit. Let's see, hold on just 1 second. Okay, so that's what we say. We are 95% confident that the true mean is between these two values. Okay, that's what we got. All right, now let's look at the other problem. Our next problem says what? Let me go ahead and exit this a little bit. Our next problem says, the operations manager of a large production plant would like to estimate the mean amount of time a worker takes to assemble a new electronic component. So assume that the standard deviation of this assembly time is 3.6. Now, I messed up here. I really did. And my messed up part was that this should have said population, because we don't know the true value. We know the true value. The true value is the population standard deviation of this assembly line is 3.6. So we know for this problem that the true standard deviation is 3.6. Okay. So what we did, we observed 120 people, And the manager noticed that their mean, so their sample mean that they obtained was 16.2. So what we want to figure out, we want to find a 90% confidence level or confidence interval for the mean assembly line. So we cannot possibly get every single possible person. So after all we just look at is the first 120, and we find that their mean is 16.2, but I want a range of values of where the true value is going to be in. Okay, so I'm going to go back here, and we still have, this is the information that we obtained. We obtained that the standard deviation, the true standard deviation, for some reason, we knew that this was it. It was 3.6, right? N is just 120 because that's how many the manager observed. And the sample mean is 16.2 with the 90% confidence level, right? So 90% corresponds with what type of Z? So let's go back up here. 90% corresponds with 1.645. Okay, so Z star is 1.645. Okay, so I'm going to do the same thing that I did before, right? I'm going to try to figure out what X bar minus Z star sigma over square root of N is. And I need to figure out also what X bar plus Z star sigma over square root of N is. So I need to figure out where is the true value, okay? X bar, in this case, is 16.2 minus Z star, 1.645, times sigma 3.6 divided by square root of N, which is 120. And do that for the minus, and I'm also going to do that for the plus. 1.645, 3.6 over square root of 120. Okay, so let's figure out what these are. Okay, so I'm going to use my calculator, and I'm going to put 16.2 minus 1.645 times 3.6 over square root of 120. So feel free to stop the video if you feel like you need to be able to catch up. Okay, so what do I get here? I got 15.6 approximately. Okay, and now I'm going to do the same thing. I'm going to press second enter, right? And then I'm going to change this minus to a plus. And what do I get? 16.7. Oh, these were kind of very similar to the other problems. Okay, anyways. So what do I get? I get a interval between 15.6 and 16.7. So what does this tell me? What does this interval tell me? Well, this tells me that we are 90% confident that the true mean time, I think that's what it was, right? The true mean time is between 15.6 and 16.7. So let me go back to the problem. I think that's what it was. It was looking at time, I think. Minutes, yes, minutes. So the true mean amount of time that a worker takes to assemble a new electronic component. So in this case, it will be between 15.6 minutes and 16.7 minutes. Okay. All right. So that is my confidence interval. This is what we get, and this is the interpretation of it, right? So this is the confidence interval. This is the confidence, and this is the interval itself, and this is the interpretation. So we are interpreting. I don't know if I spelled it right, but that's the interpretation of what the confidence interval is and what it does. So remember, this one doesn't have a mu. You don't know what it is. Central limit theorem, we knew what it was. We assumed what it was. Here, we don't know what it is. So this is why we're doing it. Now notice, one thing that should raise a red flag is that we are assuming that we know the population. Well, if we don't know the population mean, do you think that we're going to know the population standard deviation? Probably not. We don't know anything, right? So what we want to go ahead and try to do is, in class, we're gonna look at what happens when this is not known, like what happens to the entire confidence interval. Okay, all right, that's it for this one. I think this is the last round of videos. Okay, and just go ahead and watch them, and we'll have a quiz on Monday or Tuesday.